welcome to lesson number 5. Today we're going to be looking at parallel and perpendicular lines. We're going to be looking at this first example. So on the grid, we want to show the image at the point A, 2, and 5. And after the following transformations, so that a transformation is a way that we move a point around a graph, we want to write the coordinates of the new image. So first we're starting with A at 2 and 5. So A at 2 and 5 is going to be at the x value of 2 and the y value of 5. So this is A. And if I move 3 units to the right and 2 units up, this is going to move me 1, 2, 3 to the right, and 2 units up is going to put me at here 5 and 7. And this is point B. So this is at 5 and 7. Now a 90-degree clockwise rotation about the origin. So a 90-degree clockwise a 90 degrees clockwise rotation about the origin, and so the origin is A. So if I rotate this 90 degrees, then what this is going to do is going to end up taking me to 5 and negative 2. So 5 and negative 2 right here, and this would be at C. And what that means, a 90 degrees clockwise rotation, is I'm moving clockwise, and so in this direction. And if I'm going 90 degrees, then this is 90 degrees like this, in this direction, then that means my x and my y values are going to be flipped around. Next, we have a 90 degrees counterclockwise rotation about the origin. So again, starting at A, and if it's counterclockwise, it's going the opposite direction. So now I'm going over this way. And if it's counterclockwise 90 degrees, then I'm going to be at negative 5 and 2. Negative 5 and 2. So when we're looking at investigating parallel line segments, so on the grid, show the image of line segment AB after the following transformations. So first of all, we have a translation. That means we're moving either up or down, but a translation 4 units to the right and 1 unit down to form the line segment CD. So CD, we're going 4 units to the right, so with this point A and point B, we're going 1, 2, 3, 4, and 1 down. Same thing with B, 1, 2, 3, 4, and 1 down. My new line segment is going to look something like this. And this is point, oh, and hold on a sec. 1, 2, 3, 4, 1 down, and 1, 2, 3, 4. This is CD. CD. And next we have a translation, 3 units left and 6 units up. So a translation, 3 units left. So then this is from A again. 1, 2, 3, and 6 units up. 1, 2, 3, 4, 5, 6. Same thing with B. 1, 2, 3, 1, 2, 3, 4, 5, 6. And so this is line E to F. And then we have example 3 here, a translation 3 units down to form the line segment GH. So 1, 2, 3, and 1, 2, 3. And this is line GH. And now we want to calculate the slope of each of these line segments. And so the first line segment we have was AB. So looking at line segment AB and the slope, remember slope is M. So M of AB is going to equal, so we have from point A to point B, we go down by 1, 2, 3, and we have a run of 1, 2, 3, 4, 5, 6. So negative 3 over 6 is going to equal negative 1/2. Now let's look at line CD. So we'll go the slope of CD. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So again, down 3 over 6 also equal to negative 1/2 if we simplify. And now let's look at the slope of EF. So MEF is equal to 1, 2, 3 down and 6 over. So a rise of -3 and a run of 6 is equal to -1/2. And if we look at GH, likely the same thing here, MGH, a run of -3, or sorry, a rise of -3 and a run of 6 would be -1/2 as well. So all of these lines, the 4 line segments are parallel. That means they're never going to cross one another. So make a conjecture about the slope of the parallel line segments. And so conjecture is a rule based on observation. And so far we can conjecture that the 4 lines, or that parallel line segments have equal slopes. Now on the grid, plot the point A, 5, and 2. So 5 and 2 is right here, and this is point A. And we want to draw a line joining the point to the origin. So origin is always at 0, 0. And this is going to be point O. Rotate the line through an angle of 90 degrees clockwise about the origin and show the image on the grid. So if I have a line here that would form, and so if this is my line, and if I want to form a line 90 degrees to the origin, rotate it 90 degrees, this would land at this point here. So this is a 90-degree rotation, and this would be points B. And then we want to find the slopes of 2 perpendicular lines and multiply them together. Okay, so the first thing we're going to do is, if I look at my new line here, if I were to continue this line straight across, this is something that we would describe as perpendicular. So if perpendicular means it forms a right angle with another line. So again, let's read the second instruction. Rotate the line through an angle of 90 degrees clockwise about the origin and show the image on the grid. So here it is, and we're going to call this point C. And we want to find the slopes of 2 perpendicular lines and multiply them together. So we're going to find the slope, first of all, of A to O. And A to O, remember, O is our origin. So that's our first line that we want to find. And so if we're looking for that slope, then if we go O to A, then we go up by 2, so a rise of +2 and a run of 5, and that would be 2/5. Now if we look at this slope, so of O to C, we have a run of -5, and we have a rise of -5 and a run of +2. And sorry about the marker bled through here, so my apologies. Now, if we multiply these slopes together, so we're going to go 2/5 times -5/2, this is going to give me -10 divided by +10, which is equal to -1. Now, what we want to do is repeat this part A for the point -6 and 1. So I'm going to plot -6 and 1 on my graph. So there's -6 and 1. And we want to call this point B. And what I want to do is rotate this around the origin. And so if this is my line here, and if I were to make a line 90 degrees with this, it's going to be at 6 and 1. And so same thing. There we go. So if I have my slope of BO, then we have a rise of +1 and a run of -6. And likewise, doing the same thing for this point here, we'll call that D. The slope of DO is equal to a rise of +6 and a run of 1, which is equal to 6. And if I multiply 1 over -6 times 6 over 1, I get 6 over -6, or -1 again. So making a conjecture about the slopes of perpendicular lines, so the slopes of perpendicular line segments have a product. So when you multiply them by one another, they have a product of -1. Oh, sorry, there we go. They have a product of -1. Now with parallel lines and perpendicular lines, we want to call that the slope of any line segment within a line represents the slope of the line. So if I have a line, and what this is saying is if I have a point from here to here, and then I put another point here, these slopes will represent the same line because they're in the same segment. But if we're considering then two lines with slopes M1 and M2, the lines are parallel if they have the same slope. So for example, if this had a slope of -1 and I had a line like this that's parallel to this one, that means it's also going to have a slope of -1. However, if the lines are perpendicular, so if I have a line that attaches like this, forming 90 degrees, then if I were to multiply this slope by this slope, we're going to get a product of -1. And for perpendicular lines, each slope is the negative reciprocal of the other one provided. So neither slope is ever equal to 0. So what that means, a negative reciprocal, is if one line has a slope of, let's say, 5/4, the slope that's perpendicular to this line is going to have a slope of -4/5. Now we want to consider the line segment AC with a slope of 3/4. We want to write the slope of the segment GH, which is parallel to this line. So if it's a line that's parallel, the slope of GH is going to equal 3/4. However, if we write the slope of the line segment BF, and BF, remember it's perpendicular to AC of 3/4, that means it's going to be the negative reciprocal. So if my value of the slope is 3/4, that's positive. We know that it's going to be a negative now. And if it's a reciprocal, then I'm just going to switch these two numbers around, my denominator and my numerator. So that's going to be -4/3. The slope of two lines are given. Determine if the lines are parallel, perpendicular, or neither. So if I have M1, this is equal to 1/4, and M2, which is equal to 3/12, we can simplify this 3/12, divide both by 3, that would be 1, and this would be 4. If those slopes are the same, that means that they are parallel. Now with 5/7, I have a slope that's 5/7 and a slope that's 14/10. If I simplify this, this will give me 7/5. However, it's not perpendicular because this is positive and this is also positive. So this is going to be neither. And last, let's look at class example number 3. If P is the point 4/7 and Q is the point 6 and -2, find the slope of a line segment that is parallel to the line segment PQ. So if I have my slope, which is MPQ, and if we are doing this long way, this is y2 minus y1 is equal or divided by x2 minus x1. So y2, we'll use this as 0.2. So let's call this y2, and this is x2, which means this is y1 and x1. So y2 is -2, subtract 7, divided by 6, subtract 4. This would be -9 divided by 2. So -9/2. So a line that's parallel to line segment PQ would have to have the same slope, so it would have to be -9/2. However, if it's going to be perpendicular, first of all, it's going to be the negative reciprocal. So if it's already negative, that makes it positive. And then we just switch these around. So this would be +2/9.